Hi everyone, today we're going to continue our geometry unit with learning about rectangular prisms. So we're going to be talking about surface area and volume today. Alright, so surface area is the area that is around the outside of a three-dimensional figure. So using our formula to find, we're going to find the surface area of this rectangular prism here. Now, if I'm not mistaken, I believe you guys did actually look at surface area and volume of these shapes last year as well. So we're just going to kind of review that aspect of it, and then we're going to take it a step further. All right, so our formula is the 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. So we need to go ahead and identify who's our length, who's our width, and who's our height. So I've gone ahead and identified this side here, the 15 is my length, this side here, the 5 is my width, and then this side here, the 10 as my height. So now I'm going to take those values and I'm just going to substitute them in. So remember, when a number and variables are all stuck together, it means they're being multiplied. So when I substitute those numbers in, I'm going to put my times symbol in between every number. All right, now we can go ahead and do the math. So we're going to take care of all of our multiplication first. Okay. So I'm going to multiply this group, and this group. And then I can finally add them all together to get our final surface area. And it adds up to 550 centimeters squared. Since surface area is still a type of area, we have to make sure that we square our units of measure. All right, volume is the amount of space that's inside a 3D figure. So how much can I put into this box? So let's use our formula to find the volume of this rectangular prism here. Okay, so the volume is the length times the width times the height. So it's the same shape. I'm going to keep my measurements the same for my length, width, and height. And now this time, again, they're all stuck together, so they're just going to get multiplied together. And we end up with 750 centimeters cubed. So when we're multiplying, or when we're trying to find volume, we have to cube our units of measure. All right, so now let's take a look at this problem here. So this problem was actually one that we adapted and changed, so there's some extra information in here that we actually don't really need. So here we have a hamster cage, and it has this tube inside, which really has nothing to do with what we're going to be doing. Okay, they're going to replace this cage. How much glass is needed for the current cage? Well, the glass is just the 4 sides. Okay? So when we're looking at the, hold on, I didn't mean that. Let's take this out for a second. All right, so move those for just a second. I clicked in the wrong spot. All right, so here's our surface area formula. Okay? So we don't need a top or a bottom. The bottom's not glass, and the top is not usually glass either. So we're going to use this part here, my length and my width, okay? My length and my width, I don't need those. So this whole section right here, I don't need, since I don't need a top or a bottom. I'm just replacing the glass, okay? These 4 sides here. All right, so my new formula then is I'm taking this part out. All right, so now I'm substituting everything that we have, my width, my length, and my height. So now I can go ahead, substitute in what I do have, or what I do need, and go ahead and do the math. And my surface area ends up being 6 feet squared. So I need a total of 6 square feet of glass. All right, let's go to the next page. All right, now we replace the cage. The new cage is 3 times longer than the old one. What we're going to be doing, so this is kind of the new aspect of what we're doing. How does tripling the length affect the surface area? All right, so here's what we got. Our new length is going to be 6 feet, because if we remember, the length of the last one was 2 feet. Okay, so we're going to triple that, right? So if we came back here and we looked over here, the original length was 2 feet. So we triple that. Right? So it means we're going to multiply it by 3. So my new length is 6 feet. So I'm going to take that. I'm going to use that same formula that we pulled before. Again, I don't need the top or the bottom. And let's just see what happens. All right, I'm going to substitute in my new length this time. Everything else stayed the same. Okay, just my length changed. So we got a surface area of 14 square feet. So what happened? We went from, what was it before? I already forgot. Let's see. Let's go back and take a look at what we had. We had 6 square feet. So now all of a sudden, we have 14 square feet. So we can say that the total surface area more than doubles, right? It went from 6 to 14. So it increased by 8 square feet. So the surface area more than doubles. We tripled the length, my surface area more than doubled. Right? It increased by 8 square feet. All right. The Wheatley Bites cereal company currently sells their cereal boxes with the dimensions shown. Now this 2 here should actually be with this width. They hire you to help them create a box that can hold twice as much cereal. Right? So we want to make a box that holds twice as much cereal. All right, so we have a couple things going on. A box that can hold. So that means what are we filling inside? Remember, that's going to be volume. All right, so let's come down here and start answering some of these questions. How much cereal can the original box hold? So what's the volume of this original box? So our volume is the length times the width times the height. My length, my width, my height. All right, so substitute in our values and get our answer. So the volume of this current box is 208 cubic inches, or inches cubed. Now we want to help them create a box that can hold twice as much. We want to be able to double this. So what do we have to do? So the company has asked you to come up with 3 options for the new package. Complete the chart with the dimensions of your designs. For the first trial, I want you to double the length. For the second trial, I want you to double the width. For the third trial, double the height. Record the new amount of cereal in the last column. So here's what they're asking. The original length was 8, so for this first trial, they want us to double that. But we're going to keep the width and the height the same. So let's just see what happens. So when we go and substitute that into the formula, 16 times 2 times 13, right, what does that equal? That equals 416. Well, that doubled this. All right, now, as you're trying your own, I want you to go and change the width for this one, keep the length and the height set as the original, and then for this trial, I want you to double the height, keep the length and the width as their original measurements, and see what happens. All right, let's go to the last page, and then this one here is going, actually, you know, I changed my mind. We're going to come back and we're going to finish this one out together because I want to be able to talk to you a little bit more about it. All right, so when we do this, we're going to keep the length the same. I'm going to double my width. I'm going to keep my height the same. Plug my numbers in, and once again, I get 416. I'm going to keep my length the same. I'm going to keep my width the same. I'm going to double my height. Put those numbers in, and once again, my volume doubled. Okay, so these 2 questions that we just talked about, okay, this one here where we doubled the length or tripled the length of a side and then found its surface area, okay, we found that the surface area doubled, or more than doubled. There's really no exact difference when we change a length when we're finding surface area. So if I increase one length, my surface area is going to increase, but it's never by a set amount. The thing with volume, okay, is that when we change one length, if we double one length or triple one length, then the volume is going to change at that same rate. So if I double one length, my volume is going to double. If I cut one length in half, then my volume is going to be cut in half. So that's the pattern that we're always going to be looking for. All right, so you have one question that you do have to do on your own, this last page right here. So this multiple choice, I want you to see if you can figure out what's going to happen, and we'll talk more about this in class next time. I'll see you later.